panel discussion on enabling the software-defined future, policy, regulation, and collaboration. We are honored to have a distinguished group of moderator and panelists joining us today for the panel discussion. We have Kaushik Madhavan, Vice President and Global Head, Consulting Automotive and Transportation, Markets and Markets. We have Sudeep Puchamana is the head of ADAS India at Continental since 2022, driving strategy, product development, and growth for the autonomous mobility business. He joined the Continental in 2015, building R&D capabilities in passive safety and sensorics. With over 25 years in the automotive sector, he has worked with the Volvo and CG Smith, gaining expertise in electrical and electronics, including Horizon 2020. He holds a degree in electronics and communication engineering from the Mangalore University. We also have Pramod Nanjandaswamy. Pramod Nanjandaswamy brings 26 years of global automotive experience and currently leads the automotive and mobility business unit at Cient as VP and Global Delivery Head. His expertise spans SDVs, autonomous driving, and digital cockpits, integrated AI and digital technologies for global and Indian markets. He has held leadership roles at Bosch, Westion, Harman, and Capgemini, working across the US and Germany. Beyond industry, he contributes to academia as Deputy Director of IIM Bangalore Alumni Association and Academic Council member at JSS Technology University. With him, we also have Shinto Joseph, with 28 years in embedded software and leadership across safety critical industries like aerospace, defense, nuclear, automotive, rail, and medical. Shinto Joseph is respected voice in technology, innovation, and regulation. He has built successful teams and nurtured technology firms while mentoring the next generation of leaders. Currently, he co-chairs the Software Engineering Working Group at the Directorate of Defense Standards, Ministry of Defense, Government of India. A BTech graduate in computer science and MBA in marketing, Shinto interests also span macroeconomics, geopolitics, and psychology. And we have our last panelist for this session, Mahesh Shivaprasad. Mahesh Shivaprasad brings 27 plus years of global leadership at crossroads of core, engineering, and digital transformation. He has led initiatives across aerospace, automotive, industrial machinery, and medical devices, including a decade abroad in Europe, the US, and Canada. At Accenture, he drives innovation in software defined vehicles, engineering, and aftermarket services. Earlier, with TCS, he enabled digital transformation and Factory of the Future programs. An IIM Bangalore alumnus, Mahesh has managed large P&Ls, diverse teams, and global integrations, combining strategy with engineering depth. Ladies and gentlemen, please join me in welcoming our moderate and the panelist on the stage. I want everyone to put your hands together in welcoming them.
Wonderful set of panelists here. I'd like to stand if you don't mind. So, Brahman, thank you very much for that wonderful presentation. I think I learned a lot and I've made a few notes as well. Hopefully, I'll be discussing that with a few of my panelists here. So, diving straight into the topics, right? When we talk about SDVs, in fact, I was discussing with the panelists earlier this morning when we huddled. The elephant in the room is always regulation and legal consequences, right? So Shinto, I want to start with you. When we talk about the regulatory roadmap and the framework, right? I mean, we've got lots of regulations. Obviously, for India, we are still following some of the global standards, UNECE 26262, then 21434 as well. So, from your perspective, where do you see the challenges in terms of, number one, adopting the global standards modified to the Indian context, number one, and how do you see the Indian ecosystem players raising the game in terms of their own competencies and capabilities to ensure that they comply with the global legal standards? So, tell us your thoughts and set the context on how you see the global regulatory framework driving product development from an Indian context.
Thank you. I mean, it's an interesting topic. With the techies sitting here, I know you don't like lawyers, right? We all don't like lawyers, but without laws and regulation, no society runs. That's the sad part, right? So I'm coming from the same thought process that we need the appropriate rules and regulations to run a society. Same way for this SDV-based industry also, having the right standards, starting with the international standards, adopting or modifying or copying or benchmarking to the Indian context, and creating India-specific laws. Because without an act of law, which is currently not in place, anytime I'm expecting an act coming into Parliament, probably the AIS 180 and 190 series, which some of you are, it's all out there in the public domain. Once that become an act, the regulator will step in. ARA or any other organization can implement it. The advantage is that tomorrow there is a litigation, the court can step in. Right now, no court will step in because the court will ask on what basis I will catch you, right? So it's very important. Every domain is the same dynamics, so we need to have that. Now, how do we implement that? In any law, like for example, the 155 or 1556 series, which is based on the 21434 standard, which came in Europe. There also they gave a long gestation period, starting with the ECU level at 2024 and going up to 2027. A similar time frame will be given in Indian context also. Otherwise, we will all go out of business, right? With more leverage for the existing models to stringent to the new models. So that would be the time frame. Now, you need not have to copy everything. But the challenge I will tell you, unlike safety versus security, security is a national security challenge, to be frank. Automotive cyber security is a national security subject. I've been asked to give a presentation to an NSA office 5 years back. Long back, many people started talking. I come from the defense industry background. For the same reason, we need to take it more seriously. It is a national security subject. It can be used as a weapon on the road, right? That's where the SDV game taking us. So we need to be serious. We need to be considerate. Consumer play a major role. We need to educate the customers that it is not only your comfort level, national security is also important. Now, where we will go at some point of time is, I'm afraid the SDV game could be taken out of the WTO framework. It could become like a telecom gear or defense import. I'm not terrifying you, but then at some point of time, the countries could start defining, hey, it is a national security subject. I need to be treated at a different level. So today you can see countries talking about protectionism. This could be a way to protect your market. Now, the real challenge is, yes, taking all the stakeholders together. That is the most important thing. Is Brahma spoke about skills and expertise. We need to invest a lot on skilling. I spend a lot of time with the skills community because any business in India, the real challenge is we talk about engineers in India. With all due respect, I'll tell you, Indian academic system create engineers. But I'm afraid, are we creating enough systems engineers who think in terms of systems, not a lot software line of code? You don't need software developers going forward. Coders we don't need. And that's where we are. And that is a major shift, I would say, which we need to educate the academy as industry has to get into academy and to make that change happen. So finally, yes, giving the confidence to the average customer, you are not getting hacked. You're on the safe path. So that's also equally important. So I think we can go in the remaining discussion further.
Um, just have a quick update. We have Manoj Desai, who's the Deputy Director at ARAI, who's also going to be part of the panel. Manoj, if I can request you to join us on stage, please. I think just the right perspective we wanted from ARAI.
I think some of the areas which I discussed, he is the right person.
Yeah. Thank you very much. See, I saved you from bringing another chair to the table. So, thank you once again. Perfect. So, you raised a few very, very interesting points, Shinto, especially on gestation period and security as well. So, I'm going to come back to the panelists on the security part a little later. Sudeep, I want to come to you now. First of all, congratulations on formally establishing the Aumovio brand in India. That's a huge step forward. Just continuing on the point Shinto made, obviously also this is something Brahmanand mentioned earlier, which is the time to market today is shrinking, right? Maybe a decade and a half ago, it was anywhere between 36 to 48 months. Today we're talking about 16 to 18 months, right? Obviously, which country is leading the way in that. But from the perspective of competency development, right? I know you've got a technical center in India that caters to global clients. So how do you see the evolution of competencies and capabilities in India that can cater to the global market, obviously, but also from an India perspective, Brahmanand showed Mahindra there, right? Mahindra has set the benchmark in India. How do you see the gaps being addressed in competency and capability development as we see more and more software developed features becoming, omnipresent in the market?
Yeah. Good morning, everyone. Thank you, panelists, and also thanks. Yeah. So I think in the previous keynote also mentioned about working together. That is, we have also now Shinto mentioned about thinking about from a system level point of view, right? So the turnkey is the key word right now. So how can we work together, because we are moving towards domain-based control units. Then we are moving to SDVs, and all the companies are moving towards in this direction, because the features are getting much more demand of the features from the market, as well as the regulations needs this high level of software intense computers in the way. So I think one of the key thing is the system level know-how. I think that is something. The second thing is also, apart from the system knowledge, we need to also develop a lot of data. I think we talked about data in terms of data security and all. But if you look at, especially in the ADAS area, I think if ADAS works in India, it works everywhere in the world. So you take the data from Indian market, because we have oncoming traffic, we have potholes on the road, we have non-standard traffic signs. So we need to tailor our algorithm accordingly, and we need to bring a lot of knowledge in the algorithm development here. Yeah, and that is something which we need to, moving from a basic CNN-based algorithm or moving towards transformer-based algorithm and such kind of things. So we have to be very, very fast in catching up the technology in terms of AI. We need to be also look into the infrastructure part. And I think somebody mentioned about there is a lot of focus on not only from a regulatory point of view, also from the ARAI and also NATRAX and GARC and all these facilities. I think this is also very key in order to address this high level of safety aspects to be covered, so that when you develop a vehicle, it is also zero fatality, zero accidents, and so on. In this note, maybe just to conclude my first note, we are also developed from Continental now Aumovio the first auto park assist system for our Tata Harrier EV, which is very unique, which is very because it has got the live streaming of the parking. Actually, this is something very unique, and this is something which has been completely developed in India, and this is something which I think. So that means competency is not just. I think it is available, and it is only how we develop and how we utilize this, and that's important actually.
Thank you very much, Sudhir. How we use and leverage competency is going to be the key differentiator. So I want to come to Pramod and Mahesh, both of you. I want your perspectives on, let's say, a couple of points, right? Both Shinto and Sudhir mentioned about this. When we talk about legality and complications, right? It's always the fringe cases that determine, regulations, right? The roadmap for regulation. So OEMs are always building redundancies in the systems, right? It's those 1.5% of the fringe cases that have a significant impact, whether it is related to fatalities, like we mentioned, or any kind of accidents. I saw a couple of videos as well that are doing the rounds where there was a model involved in an unfortunate incident, at one of the dealerships in India. So, from your perspective, when you talk about product development, how do you account for, let's say, those fringe cases, and how do you build redundancy in your, let's say, algorithms, software, and your platform so that even those are taken care of, although the probability of them happening probably 1 in a million or one in a few million. So, tell us from your perspectives, from a product development perspective, where you see the efforts being put by you and also by the OEMs to ensure we achieve, let's say, zero fatalities. Maybe zero accidents is still a bit of a stretch, but at least zero fatalities is something we can achieve. Your thoughts there?
Yeah, I think there we have some sort of a, if I have to say, standard set with functional safety guidelines, right? SLA, B, C, D. So that acts as at least some sort of a framework which will help us to comply with, if I have to say like that, right? And then whether it's designing or developing, we always cross-verifying with whether we are compliant from redundancy standpoint or fault handling standpoint, right? So that helps us to go in a direction which is already clearly defined and a path has been set. So that at least is a good starting point. But where it always becomes a challenge is this algorithm, the CNNs or the RNNs, right, where it is more like a black box, and whether have we handled all the edge cases, and that's where some of this simulation-based testing, right, where we try to create the simulations or some sort of a data that will handle the edge cases and see if we are covering all the cases that are more or less covered. I think that's where exhaustive testing, both in the simulated environment as well as in the field, collecting a lot of data and then running through, that's where the Teslas or Waymos of the world are spending effort, right? It is, I think achieving 90, 95 is not a challenge. The last 1.5% is where you may have to spend 20-80 principle, right? The 80% of the effort goes towards probably last 2 to 3% increasing accuracy. So I think that's where the effort is going to handle those edge cases and also coexistence with the human world versus the automated world. So these are the things, and particularly again there is always some localized behavior that we may not have, probably somebody raising their hand and say stop, which the vehicle may not understand, right? So our traffic police controlling the giving the hand signal. So training in some of those localized cases or environment. So these are the things where majority of the effort is going, and that's where the challenge also lies.
Yeah, nice your thoughts there.
Good morning. Thank you for this opportunity, and good morning all the panelists as well. So I look at it from two perspectives. There's a lot of in-car software and there's out-car software. I think both are important now with the way SDV connects or the connected ecosystem exists in the market today. So for the in-car software, I can draw a parallel actually. I've had the good fortune of looking at both aerospace from a functional safety standpoint and automotive as a from a functional safety standpoint. Automotive so far has been, functional safety is a sidebar item. Aerospace safety is by design because of the redundancies that you have to build in. All of you could imagine that one aircraft accident and everybody knows about it. The entire world knows about it. So there are a lot of redundancies built in there. So what I'm seeing increasingly in the product development life cycle is a lot of these tenets of safety in aerospace is being brought into the automotive world. Having said that, that's a long cycle for aerospace because the products last much longer. And you said it just now that the time to market is being shrinking for the automotive world. So obviously there's a lot of adaptation that is being done in terms of bringing in that safety angle, but at a much quicker pace. I think technology is helping to a large extent there. The CI/CD pipelines, the DevSecOps model of pumping in software into the car, and so on. So I think the product development is evolving differently for out-car and in-car software. In-car software, there's more focus on product cybersecurity that's being put in place, and for out-car software, there's more of cybersecurity at an enterprise level that's still coming into play. So these two are coming together and converging in a way that enterprises are thinking differently on how to make car secure, and of course, looking at curation of the safety aspect from aerospace kind of domain, which is highly safety critical to the automotive domain. So these are my thoughts.
Yeah, excellent. I think that safety critical functionalities from aerospace, I think we've got a lot to learn, that can be adopted by the automotive industry. Which I want to come to you now. With AR AI, we've always associated AR AI from a homologation certification perspective, right? Now with SDVs coming in, that also means that I think Sudeep also mentioned about it. It's an increasingly collaborative ecosystem, right? You've got NatTrax, you've got GARC, you've got IRD, NatTrip. Multiple organizations pretty much working towards the same end objective, right? So from a homologation perspective, as you see time to market shrinking, you are seeing more and more vehicles that are coming to you for homologation. So how do you see the evolution of the testing standard itself or the homologation standard itself, so that essentially we are ensuring vehicles that are compliant, number one. And also a second part of the question as part of homologation is that for me the best example is when BS7 comes into the Indian context, right? When Euro 7 comes in, one of the most significant aspects is on-board compliance or real-time compliance, right? Which has never been the case in India before. So even for SDVs or ADAS, autonomous, real-time compliance is very, very important. So tell us your perspectives on how you see the entire testing, homologation, certification ecosystem evolving in that direction.
Yeah, good morning all. I think Shinto has already spoken about the regulatory requirements. So in under United Nations Economic Commission, so they were coming with two regulations. One is on cyber security and software update management system. So based on that, similar in India, we have two regulations which are formulated, which is 189, AIS 189 and 190. The good thing what you ask is, what I feel is this, with this software update and the software defined vehicle, it will be a dynamic homologation kind of situation. So if you look at the earlier days, the legacy vehicle, whatever new changes or new features or new models, those are introduced in a batch-wise manner, right? Okay. But henceforth onwards, with this, even last couple of 2-3 years, with this electric mobility coming into picture, a lot of vehicles are coming with subscription-based driving modes or models which are AI adaptable. And when we, as a test agency, we see from homologation, it will be a continuous interaction with OEM, because it's a dynamic situation. You are changing something you need to inform to the authority. Authority will assess like what is its impact on safety, security, and any other regulation which is already in place. Then you are assessing it, testing, and provide the homologation. And manufacturers will be allowed to implement those changes on the vehicles which are on road already. So earlier date, it is like the new feature is coming in the new vehicle after homologation. But with these software defined things, the features will be provided to the vehicles which are already registered. So I feel it's a dynamic situation where test agencies and OEMs will be continuously interacting, informing about the changes. The changes could be for addition of feature, it could be for fixing bug, it could be for optimizing the performance. So many which we saw so many new features which will be coming. So there is a continuous homologation which I feel which test agency need to gear, and that is why we are also putting efforts to establish, to interact with OEM, to understand, to inform the new regulation, to tell them what is the requirement in the regulation, to build that competency, to build the test facility.
Excellent points there. So dynamic homologation, I didn't know about this at all. So I'm glad to see that homologation is not going to be a one-time thing anymore, but it's more of a continuous process as you go forward. So I want to bring this point next to Shinto and Sudeep, both of you, right? One of the key areas where we see investments by the OEMs is, let's say, simulation in digital twins, right? A digital twins investment from a perspective of, let's say, how do you predict performance of anything, right? Any component, any part, or any vehicle for that matter. So from a long-term perspective of, let's say, diagnostics, predictive maintenance, and so on, obviously from a software-defined vehicles perspective, a digital twin or a simulation, at the OEM is going to become even more important, right? So, Shinto, from what can we learn from aerospace, right? From a digital twin perspective that can be adapted to the automotive ecosystem, and Sudeep, as a consequence of that, how do you see you or any of the tier one ecosystems leveraging digital twins and simulation? So, Shinto, you want to go first?
So in aerospace, because for me this is around 30 years I've been with the aero community. In that community, adoption of tools or practices, there was no questions asked. People were in the front because primarily I believe there was no workshop in the air. That was the bottom line, where the practices were adopted, any technology adoption also, they were pretty open. Now, the challenge there is actually you have a wider, long life cycle for aerospace business. 10 to 15 years is nothing in aerospace industry. Whereas in automotive, months matters, right? So that adoption and the mindset shift. But I would say in Indian context, the maturity level is slowly coming up. 10 years back, when I was talking about adoption of tools in digital twin or test automation, people were skeptical. Now, if you look at, I work with all the Indian OEMs, whether it's Mahindra or Tata or TVS, all of them are ahead in the race when it comes to tool-based automation or simulation activities, which is a good sign. That means our market is, the players in India is ramping up in the same way their counterparts elsewhere. Right? There are challenges. The real challenge is actually lack of skills itself. At the academia level, much more need to be done to this acceleration, and some of these tools are pretty expensive. So that is where actually the facilities IRA or other organizations are creating right now for SDV. I'm sure it will address the startups community because they cannot invest in any of these tools. So I'm sure government involvement will play a major role. Mindset shift, I'm pretty seeing very positive. According to me, academia need to raise the bar. Right. You cannot blame academia. Industry only can help.
Right.
You have this concept of professor of practice. I request each one of you sitting here, look at the nearby college, go as a professor of practice, fill the gap, and add further.
No, I think Sudeep. See, basically, again, the simulation and those kind of things, right? Where it helps is if you have already simulated, you have the building blocks. Now, assembling them more like how you assemble any other puzzle, right? And how do you measure the performance? Is it in line with what you are intending? How do you then go back, tweak those parameters either from a sensor standpoint or from a configuration parameter of the engine torque or any of it, which will give you the kind of power or the positioning that you want to have the vehicle. So it makes the life much more easier. What you end up developing much more predictable, and majority of the issues you find out early in the cycle than at a later point of time. That's where the simulation helps. Even from a verification, validation, right? It is, you can sit anywhere and try to still do your part of the development. The global distributed development also helps in this angle, and that's where the whole digital twin makes life easier. It takes longer to build in the initial phases. That's where the challenge is, and majority of the people run out of patience because somehow where they want to get to, they are never getting there. And are we in the right direction? And is the investment giving us enough fruit? Those are the initial in a way starting problem. But once you have your infrastructure and the whole digital been set up, that's when you saw the benefit of further simulating, further product development, further testing becomes much more easier, and that's when you start seeing the value. I think all OEMs, and we see right lot of work for us as tier 2s comes in virtualization, model-based development, and simulation-based testing. So that's where the future is, and that's where all OEMs are also in.
Yeah, I mean, excellent points there, Pramod. Sudeep, please continue on that, especially on simulation in front loading, right? One of my industry colleagues is here today. Hopefully, she will be part of the panel discussion in the afternoon talking about front loading. So tell us your thoughts on how you see the entire shift towards the first half of the product development life cycle impacting SDVs.
I think the development, especially what technology we select is very key here. Right. Maybe I'll just a little bit cover on the late, because everybody is focusing on front loading, and so I'll just focus on a little bit on the later part of it and Please. How we learn from the later part of development actually. So now if you look at it today, when you have a problem in the field in the vehicle, you get the problem and then you take a small issue, take 2 weeks to fix it. Maybe a medium or a complex issue will take 2 to 3 months to fix it. With this digital twin coming in and your back office is being very strong, and you don't have back office working like core engineers working on your back office, where your algorithm developers, because I love algorithm, that's why I'm touching upon that several times, because you have this example in ADAS, you have a problem on the field, you get the data back on the cloud, you are immediately getting back the data onto your desktop actually. Right. And then because of the kind of algorithm like transformer-based algorithm, AI-based techniques what we use today, I think we are reducing it in the significant, and a medium or a small issue we are able to fix it in 3 to 5 days instead of 2 to 3 weeks actually. And the maximum recovery time or the time is around a month's time. Where previously we used to take around 3 months to 4 months a complex issue to get analyzed, fixed, and then get back to the software, back to the market basically. Yeah? So I think it's very, very key that this is also maybe just to time to respond actually, which is really saves a lot of time. So I think it's very, very important for us not follow what Europe and US or the China does actually. It is also, we have a lot of talents here, and I think how we catch up much faster in all these aspects. Maybe just one last point I'll make it. This is not exactly on the, it is not in the front loading, it's not after the development, but during the development actually. We also are very, very dependent on again, I'll take the example of ADAS. Yeah? It's very, very dependent on what is the head unit, what is the brake system you use, what is the steering system you use, and how we can work together as a from the beginning. Maybe a little bit of front loading there for sure, but how we can work together, how we can integrate all these components in the vehicle and develop together, and making sure all suppliers, because maybe head unit is developed by somebody and ADAS is developed by somebody, brakes is done by somebody. How can you make sure that all the softwares are available to every parties at the same time, so that this is also is a very key actions. So as somebody mentioned earlier, I think vehicle manufacturers are becoming more of a moderators and making sure everybody comes together and making sure how fast we can develop this.
I like the point you mentioned, Steve, the time to respond. So Mahesh, I want to continue with you on that. So from your company's perspective, right, you work with stakeholders through the value chain. OEMs at the top, then tier 1s, tier 0.5s, tier 2s, tier 3s, everybody, right? So from his point, which is a time to respond, which probably is one of the most critical aspects to, let's say, a fleet operator, right? A commercial truck operator or a passenger car fleet operator, right? Who have autonomous vehicles, let's say ADAS equipped vehicles on the road. How do you see this becoming a differentiator and, let's say, a make or a break kind of a situation where the time to respond and the criticality associated with it will determine what kind of software and what kind of features need to be coded?
I think there are two aspects to this. One is, of course, if there is an issue on the ground and if there and probably something has gone wrong and if somebody has to respond, it could be the tier ones, it could be the OEMs, and so on and so forth. So one aspect is from what we see, there is most of these operators are setting up the operations centers. So typically live monitoring, tracking of some of these vehicles, because most of these are cloud enabled. Like Sudeep said, there is data that's coming in right at the desk when an event happens. So these operation centers are responsible for reacting to an event. So that is one change or shift that we have seen. The second aspect to it is there is a plethora of vendors now that has to come together to do this. So the architecture plays a key role in terms of determining where the real problem is, because the reaction time has to be very quick. So it could come from different kinds, like you said. It could be a mechanical issue which is triggered this. It could be, I think, if you look at the shift, earlier any incident used to be driver specific, or the driver had the liability. Now that liability is shifting slowly towards different parts or different, even to the software bill of materials of welfare. So I think the cohort that actually determines the overall system performance is becoming larger and larger, and hence that orchestration from the OEM is becoming important. The liability is, of course, coming on to the OEM at the end. If there is an accident, we talk about the OEM and not anything else from the car. So I think the reaction time of the OEMs is going to be important going forward, and hence there is a need for orchestrating this very closely with all the vendors that's coming together to make this algorithm happen.
Pramod, if you can continue on that, because you are responsible for global delivery at Cyient, right? The point Mahesh made on how do you orchestrate that addressing of the problem, first identifying it, addressing the problem and making sure that it is one seamless operation from beginning to the end. How do you see that evolving?
See, we see more emphasis on predictability and prevention also, right? Where, first of all, you, as much as possible, predict that something is going to happen. And how do you reduce the downtime of the vehicle or whatever incident from happening or some breakage happening. So that's where the first level of focus happens. And assume you cross all those hurdles and something happens. How do you enable the driver or the person, even a service engineer, in more or less coming to a conclusion what the issue is, right? That's where even now, if you see, that's where majority of the solutioning investment is also happening, is more or less all the manuals, all the vehicles, data, everything is digitized, and we have something called chatbot based servicing, right? Where probably you take a picture of what the error you are getting on the vehicle or what problem is there, and the driver himself start interacting with the vehicle as if vehicle is speaking to him what he needs to do. Is it the problem he is facing? Level 1, level 2 is more or less there either through WhatsApp or through an app of the vehicle. So then if all of that is still not addressing his problem, then what needs to be done is already told to him, either make a call a service engineer, right? And then by that time the message would have gone to the service engineer of what the problem is. He would have already done some sort of analysis. So, and digitization of course helps in him going through and pinpointing, and even the simulation that we spoke about, right? Probably is it a wire harness? Then is it which wire harness that he has to take it back for servicing? So all that would have already told, we would have got information based on the incident. So this that's why digitization, virtualization, and whatever the AI based predictability is where the market is heading, and most of the solution is already there, particularly in the commercial vehicle or the agriculture machinery or the mining vehicle, where these are capex intensive vehicles, and downtime and incidents could be very costly.
Absolutely.
And emphasis is more on prevention and predictability.
So essentially establishing that protocol, that looks at, addressing a problem, and creating that solution is going to be very critical to ensuring productivity and uptime, especially for fleet operators.
Yeah, that's why we have big teams working purely on aftermarket technical publication, document, digitizing them, and aftermarket service support, enabling more like chatbot based services, app based services.
Understood. Understood. So, Manoj, I'll come to you before I open it up to the audience for questions. Again, it's one of my favorite topics as well. Shinto touched upon it, which is the academia industry collaboration, right? There are a few very, very bright spots in India. We've got IIT Delhi, we've got IIT Madras, who are working very closely with the industry. They've got startup incubation cells as well. So at the forefront of developing competency, right? And I think IIT Madras was the first institute in India to actually develop a new course on mobility and e-mobility, right? Gone are the days of just mechanical engineering or something like that. So how do you see, the Arise, Natrax, Natrips of the world working closely with the academic institutions, not only to set homologation and testing protocol, but also to develop the next set of talent and competencies in India?
So already test agency like ours, we have our own academy. We have collaborations with such academic institute, and we do in two ways. One is a small proficiency improvement kind of programs for the industry leaders, so that what is new is coming or what kind of requirements are there, we can explain them. That's one thing. Those are short duration, but we do a lot of master education programs with this institute, where specifically as per industry requirement, it could be e-mobility. Nowadays we are focusing on cyber security. So we are working with skill development, we are working with academia, and such courses are made available so that industry can take benefit. One good thing which I want to add, one more is, if these new regulations, those are completely different from earlier legacy kind of thing. So this talks about the complete life cycle of the vehicle. So right from the concept, your design, development, production, operation till decommissioning, because it's working on security, data privacy. So till the vehicle is decommissioned, the responsibility lies, and how do you handle? So one thing is the important is management system in place has to be there, which will help foster culture with the OEMs. And there are everybody is knowing, like software identification numbers are being talked so that it can be linked. So we always try to focus what is upcoming, create short duration courses as well as some strategic long duration where the easy trained manpower can be made available to the industry.
Yeah, I completely agree with you. I think life cycle management is becoming an increasingly important topic, because product development, first life is pretty much well understood, but second life, third life, and maybe even scrappage as well, right? That is where we need to invest a little bit of time and effort. Hopefully, we will see more investments there. So I want to open up it opened up the audience for questions. Anybody, please raise your hands, introduce yourselves, direct your questions to one or more panelists here. Anybody? I think we can take 2 questions before we wrap up this session. Anybody wants to go? No one? Come on.
Before I conclude, I think one of the important, we talked about industry, academia, we talked about tier 1s, OEMs, everybody. I think one of the players what we missed here is the semiconductor suppliers. Yeah, I think they play very, very important key role in SDV and also in all these domain-based systems actually, because today we do a lot of demonstrations in India, which is using very high-end, example in ADAS, they use LIDARs, then they use NVIDIA chips and all these kinds of. I think what we need for our country, first is to address our A, B, C segments in this one, and this semiconductor partnership collaboration makes a big impact, because we need a very cost efficient chip, high efficient, cost efficient. On top of it, we need AI tops and whatever extra stuffs here. So I think it's very important to also consider this part in our journey throughout to the SDV as well as for the future regulations.
I know that's a very good point. I know if there are no questions, I want to summarize on that point. So excellent perspective there, Sudeep, when you said, I think one of the key areas that we are also talking about in the software-defined vehicle space is decoupling hardware and software, right? Sorry, is there a question? Yeah. Oh, perfect. I'll come to you. So obviously that's an area where a lot of development and discussions are happening. How do you make it more accessible to third-party app developers and software developers to be able to bring in features into the vehicle? So hopefully that will also enable capability and talent development as well. So we've got a question here, please.
Yeah, thank you first of all for the insightful discussion. I would like to hear your thoughts around the insurance space. So who owns the damage? How do we address that? How do we pass on the buck?
The question is very, very straightforward. How do you pass on the buck?
Okay. Germany is the first country brought in an insurance law in this space. Years back, somebody from Germany reached out to me to work on such a project. I said, I don't want to be on the sides of both sides, because I work with my customers. Now, the answer is very simple. The details is there, the devil. In the sense, you have the regulation coming in. We need to build on the top of that. The first court case, court need to be probably at that time will come up with more creative questions. They'll throw it back to the lawmakers. In the second revision of this regulation, you will see these issues getting addressed. Until and unless there is a litigation, you're not going to see much in this space. So globally, if you look at, the regulatory and related, litigations, including accidents, the first case is a trigger point. Let's hope that case doesn't come up, but whenever it comes up, all will scratch their head. Something will come up to our lawmakers. The next revision will address it. Thank you.
I think assigning liability has been one of the key areas, and one of the best practices that I have seen, from my powertrain engineering days is what's called as SSR, right? A shared stakeholder responsibility. That's the only way forward, right? Through the value chain, if we are able to assign responsibility that everybody, takes a little bit of that, it's going to be a big step in the right direction, because I do not believe that any one stakeholder should be liable or should be held responsible for any incident or any kind of unforeseen situation. So, any question? Yeah, there's one more here. Maybe we take that and wrap up. If we can have the microphone there. Oh, you have a question, please.
Thank you for the insightful and the regulations and the SDVs. It was very useful. Right now in the industry, there is a buzzword going on like a chiplet, right? So how do you see chiplet it's a hand in hand for the SDV, or what's your view on the chiplets when we are talking about the SDVs?
Who wants to take that, chiplets? Anybody? or maybe Brahmanand can answer that question when he spoke about, I saw chiplets in one of the slides, so maybe he can answer that question, unless anybody on the panel wants to take that. Yeah. Yeah, if you want to pass the microphone to him, please. Yeah.
If somebody is from semiconductor, I would welcome them because they would be the right people to talk about, because we are on the other end.
Right.
So we always engage with semiconductor vendors to be ready, because we have to work in the hint side to be prepared. Software and the chipsets should go together. But definitely, I think there is a lot of work happening on SoC side. I wouldn't talk about chipset. It's wrong for me to talk without understanding it deeply.
Right.
The SoCs are also coming. New SoCs, rather I would be wrong to say coming, but they are already in the market, at least announced by major semiconductor vendors, which are updatable SoCs, right? So you develop with an SoC, the HPC today, down the line 4 years later, the semiconductor vendor can update it. I don't know what they do through the 5G or connectivity, just open up a kind of bit 0 to 1, and then it's MIPS just doubles or triples, and then you can go on. And there is a monetization models also that semiconductor vendors are looking at. They would charge you for that then, not now. So this is also like, spare hardware resources, but you're not paying now. When you need, you pay and it gets enabled. So, and they are also looking at developing these SoC, the capabilities over time, and then deploying it over there. That I'm aware. But chiplets, I think we would ask some semiconductors.
Excellent, thanks. I think subsidizing or making affordable in the beginning and monetizing it at a later stage. Sorry, we've got one question there and then we wrap up.
So hello. So my question is with Sudeep actually. He claimed that earlier how to resolve the issue, it was taking a long time, around 2 to 3 or 4 weeks, maybe months. So now you told that it is taking a few days, right? So can you share some insight, like the best practices you are following to catch those issues early?
Yeah. I think one of the example is, I can take it from ADAS side. Yeah. I think previously we have to, example, you tag a three-wheeler. We have different types of three-wheelers in the this one. You collect the data, then. Okay, maybe just to explain the overall picture. So you need to have to train your models for each and every object. Example, animal. You need to train every animal. That is how our traditional CNN algorithm works, basically. So now with this new transformer-based algorithms and what do you adapt for the future ADAS perception algorithms, you just need three-wheeler, then it can also train itself, so that you reduce a lot of time to train your algorithm, basically. You have one three-wheeler, then you can actually, you can predict this could be this shape, yeah? And then you can actually apply the brain accordingly. So this is how you try to work on the back end basically, in order to have a faster response.
You are developing the better solution, simulations type of thing, by developing or training your algorithm.
So you get the data, this data you feed it into the cloud dynamically. It is happening in every, when you drive on the road or when you stop a vehicle, depending on what is your system, you can upload your data onto the cloud and you can train, you can actually update the algorithm, and you can then again flash it onto the vehicle back. So the time you take, you don't need to take the vehicle into a service station. You don't need to, and this is already on the field today. And I think we have to adapt, and how we will faster respond to these kind of technology. This kind of demands is very important.
Excellent.
Thank you.
Hopefully that will be part of the dynamic homologation as well that Manoj spoke of. So thank you very much once again, panelists. Thank you for sharing your wonderful perspectives. Once again, I thank Nabil and the entire IRA team for this opportunity. I hope you all have a fruitful event and interactive discussions with all your attendees here. Thank you very much once again.